Hey guys, it's BlockchainBrad, and today I'm very honored to speak with Jordan Fried. He is a very important person in the Hedera Hashgraph executive team, and he is actually the VP of Global Business Development. So Jordan, thank you very much, mate, for coming on the channel.
Pleasure to be here, Brad. I'm a really big fan of your channel.
Thank you, mate, and I'm a big fan of your view in your apartment, so thank you very much for taking the time this morning. So let's talk about you for a moment. You have a very interesting background. You've done quite a few things in the blockchain space. Give us a bit of a rundown.
Yeah, so my background is I spent the last 7 years in Central Europe, in Budapest, Hungary, of all places, and ended up starting a virtual private network service, a VPN. The model is pretty familiar. We helped users unblock geographically restricted content. So Brits down in Australia that are trying to watch BBC iPlayer, or Americans trying to access the American version of Netflix abroad. It ended up being the case that in 2013, our customers started demanding an anonymous payment method to go along with their anonymity service. And we started accepting Bitcoin as a payment method. And that was back in 2013. We integrated BitPay through the digital currency group. And it really wasn't until Buffered, the company was called Buffered.com, still exists today. It was acquired at the beginning of 2017. That's really when, not having much to do and just having a nice exit there, I decided to take a look at the underlying technology and made an angel investment in Swirlds. And then ended up, Swirlds is the company that's, by the way, behind the Hashgraph consensus algorithm.
Yes,
so it's a company founded by, company founded by Dr. Lehman Baird and Mance Harmon. So interesting way that I found the project, and then ended up joining the team full time, where I serve as head of global business development. What that really means, Brad, is it's developer advocacy. We advocate on behalf of the developers in our ecosystem, and really blockchain developers at large, to integrate aspects of our technology stack into their platforms in both permission networks and public, not public networks.
I'm glad you mentioned that also, Jordan, because we're going to go and unpack those two components of the blockchain, the permission and the permissionless. But let's talk now. You've shown your credentials. You've shown you're qualified for this job, and that's important for the viewer. But let's get into the crux of Hedera Hashgraph itself. It says on the internet that you are the trusted layer of the internet. Doesn't tell us much there. But perhaps one of the best ways to really tell us is tell us what problems you're addressing.
Yeah, so to do this, we have to go back. We got to go back quite a bit. We have to go back, and I'm going to briefly talk about the different types of consensus that exist today. And then I'm going to tell you why Hashgraph is the future, the future of it. So to go back,
I'm really glad you're going to, because there's a great video by Lehman that tells us the 4 preceding ones. So if you haven't seen that, you can see that as well.
Yeah, please link that. I think that's a great video. Lehman explains it far better than I will, but I'll give the Cliff Note versions of it. And I think it's important to note that a lot of the market, especially these enterprise systems, are represented by these leader-based systems. These are represented by Raft or PBFT. Hyperledger uses this. Microsoft Cocoa uses this. And what you end up seeing in these leader-based systems is that you have a single point of failure. You have a leader that's setting the total order of all transactions in these systems, and you're trusting that leader. And that's a problem, because if you picture a triangle with all of the nodes being at the bottom and the leader being at the top, all the nodes at the bottom are trusting the leader and sending transactions here. But if any one of those nodes is compromised by a hacker or disgruntled employee, that node can disclose the IP address of the leader in that system, and one could direct a denial of service attack at that leader and take the entire network down.
So essentially, in the layman's terms, you could have a rebel who then decides to protest against the system and then wreck the network.
Exactly. And by the way, there's variations of this that exist in the marketplace today. There's round robins, where sometimes the leader will shift, and it's not necessarily this node, it may be another node, and then it's constantly rotating. It still doesn't matter, because if one node is compromised during the consensus process and they know the IP address of the leader, this IP address can get out. You would direct that denial of service attack at the leader, and the network would respond then saying, oh no, we're being DDoSed. Let's make a new leader. But that node, every node gets the IP address of the new leader. So it's a game, and it would go on and on and on, and it would never end. And it doesn't have fundamentally strong security properties.
Right. And Jordan, what's important, I think, to ask you then, in the context of addressing these preceding algorithms, no doubt attached to these algorithms is real companies, is real projects that we know and love. We won't name names, and that's certainly a policy that I respect that Hashgraph has. But implicitly, there are these connections. So are you suggesting that essentially you're redressing a problem in the context of current blockchains?
Absolutely. A lot of what you see in the market, it relies on leaders. They may be called central authorities, or they may be called leader nodes, or something private. And sometimes the code is hidden for how these operate. But they're leaders. Fundamentally, they're leaders, and that creates an element of centralization in that algorithm, and that's a problem, especially at scale. When we're only going to see additional attacks forming, even attacks that many in the marketplace aren't really considering.
Right. And in that context, just to, again, to show some respect also to the current projects we are seeing emerge in the marketplace, are you also cognizant of some of the statements they're making with regard to the iterations they're making, the efforts they're making to gradually decentralize and thus move away from some of these centralized aspects of their current design?
Absolutely. I think it's tremendous. I think that the ecosystem is evolving, and I'm proud to be part of it. And what I would say is we disagree fundamentally with a lot of what we're seeing happen. Namely that let's jump a little further, Brad, because I think this would be helpful context. Where we then see is proof of work. Everyone's familiar with proof of work. You got Bitcoin, you have Ethereum. Proof of work is much better with attack resilience, but what you end up having is very slow throughput.
Yes.
And many people are familiar with this today. We're talking but just a couple, maybe a dozen transactions per second. You're really not going to achieve that scale. It's also very inefficient. Every node in the network must receive every transaction. You've got major power requirements to be able to do these computations. And it's also not fair. The property of fairness doesn't exist there. You'll never know the order of transactions because if you're a miner and I'm a miner, you decide the order of transactions in your block when you add it to the chain. I decide the order of the transactions in my block. Right. So you're never going to run things like a game or things like that. So I'm quickly moving here, but I want to address your question.
Yes.
Where we end up seeing the marketplace going, you have economy-based systems. And the one quick thing I'll say about economy-based systems, what I mean by an economy-based system is the Casper proposal for Ethereum, things like this. They're meant to be models of economies, but they rest on fundamentally flawed assumptions. And those flawed assumptions are that every node will act rationally. Every node will do what's best for them to maximize how much they'll earn as a validating node in that network. That's a really bad assumption because viruses can direct nodes to do irrational things. And the real question, Brad, that we're trying to solve for is, can one node on a network disrupt consensus? Because we don't want that. We don't want that system where one node can do that.
Right.
And economy-based systems don't sufficiently answer that question. So what we end up seeing is 30 years ago, there started to form this academic research around a type of system called a voting-based system, pure voting-based. There's a lot of papers published on this, but no one's ever deployed one because they have unrealistic bandwidth requirements. How these work is that every node in the network submits a vote. But if nodes are offline and you're waiting for every node to submit a network, it would take forever to come to consensus. We would never come to consensus. But they have the best security properties. You cannot do better. And there's an academic definition of it, and this is where I meant to answer your question. It's called ABFT, asynchronous Byzantine fault tolerance. And what we're seeing in the marketplace is people recognizing that that is the standard. You cannot do better than ABFT, but what they're doing is they're making variations of it. They'll say something like ABFT secure. I just called someone out there. So, you putting another word at the end of it or calling it partially ABFT doesn't make it ABFT. There's one academic definition of ABFT, and Dr. Lehman Baird is the only person on planet Earth to be able to achieve a distributed system that will be deployed at scale. That's ABFT. And I think that's a remarkable achievement because now now you can start talking to banks. Now you can start talking to central banks. And we're doing just that.
I think that's a perfect segue into the very question of what is Hashgraph, because that was the leading question in with regard to your ABFT. Clearly, you've explained that it is the underpinning algorithm or the protocol for the entire platform which we're going to discuss. But in that respect, let's talk about the what. But I also wanted to sort of segue in and ask, given that it is fundamentally an algorithm, surely that can be something applied in other blockchain architectures as ABFT. Is that correct?
Absolutely. And to answer your question, what is Hashgraph? Hashgraph is literally let's say it's evolved from these voting-based systems. That was the starting point that Lehman really started with. And the question is, well, how do you deploy one of these voting-based systems? And that's really where the light bulb came on. And it was, well, we'll do virtual voting, which is we call gossip about gossip. And the way this works practically is no votes are submitted over the network in Hashgraph. What we do instead is every node, when a new event in Hashgraph, a block is an event. When a new event is submitted across the network, what we're really including is 2 small bytes of information. And those 2 small bytes is the digital signature of the last transaction in your local copy of the Hashgraph and the last transaction you received from another node, another participant on the network.
Right.
And Brad, by adding these 2 small bytes of information, they're tiny, these 2 tiny bytes of information onto every transaction on the network, what we're able to do is build this incredible data structure with incredible throughput, because we're not submitting a vote. We're just adding 2 bytes of information. We're achieving fundamentally the very best you can do, not just in security, but in bandwidth. What we're doing is we're building this data structure called the hash graph. And it's called the hash graph because it's literally a graph of cryptographic hashes, a graph of these bytes of information on who's talked to who and when. So when it comes time to achieve consensus, Alice never needs to ask Bob, Carol, and Dave what they would have voted, because she already knows Bob, Carol, and Dave's vote, because she can see their local copy of the hash graph. And we trust that local copy. We don't trust them, but we trust their local copy.
Right. And there's also certainly available on your website and many different, I would imagine, written statements and written examples through various Medium channels, some clear graphics about that. I've seen some of those circles and the
Brad,
lines.
Have you seen the documentary that Mike Maloney did?
Yes.
Gold Silver.
Yes.
Yeah. His animators did probably the best illustrations I've ever seen and the best explanation on how Hashgraph actually functions. I think your viewers would really get a kick out of watching those.
Absolutely. I'll make sure we link that. I'll have to go and find the link as well, Jordan. But let's talk about now in the context of 3.0, because it's perfect, again, the segue into the conversation of current, really progressive blockchain architectures. You arguably are the most progressive when it comes to your algorithmic design. So let's talk about it in the context of being an actual distributed ledger technology for the real world right now. Why would you argue that you are leading the way?
That's a great question. I would say to do that, we got to go back to 2008. And I'm going to tip my hat to a fellow or a group of people named Satoshi Nakamoto. So, if we talk where to know where we're going, we got to know where we came from. 2008, the world changed forever, fundamentally. I mean, decades from now, we'll look back. That was this watershed moment where we were all introduced to this concept of distributed trust at scale. Really, like Bitcoin has really caught on, and a lot of people are new and coming to this concept. The markets then really come to appreciate that what we're really talking about is a ledger. We're talking about this ledger, and then the question becomes, what else can we do with it? And I would say Satoshi's white paper is Gen 1. Gen 2 is attributed to Generation 2 is, let's say, we're seeing title deeds to properties. We're seeing intellectual property rights to things like music and other art being put on ledgers. We're seeing licenses, accreditations. We're seeing diplomas. So that's really Generation 2, other utility for these ledgers, these distributed networks. We attribute at Hedera, we attribute Generation 3 to smart contracts. And, this ERC20 token standard, while it's really being used to create these ICOs, these token offerings, fundamentally, it's going to do far greater things. It's going to be the basis for escrow contracts and derivatives and employee vesting agreements and all these really creative things. So we would say Gen 3 is the smart contracts, which mean in a distributed system where all this value, how do I give you my Bitcoin and you give me the title deed to your property? And I think smart contracts are really going to be used for things like that. And they already are. Now, generation 4 with Hedera Hashgraph, we feel we are ushering in this 4th generation that will be dominated by fast, fair, and secure consensus. And I say fast because we're doing hundreds of thousands of transactions per second. I say fair because we have a provable definition of fairness, and we generate a fair order of transactions, which enable you to build things like stock markets, auctions, games, MMORPGs are being built on the Hedera platform. And then security, I'd say security is probably the biggest, because if we're being honest with each other and we're being introspective, there's no one deploying mission critical applications today. But I see a future where FEMA, the Red Cross, the NYPD, the Sydney Police Department, these organizations are deploying mission critical, life-saving applications that are emergency services that are on public networks. And I think that future is not too far away. Right.
So essentially what you're doing is you're bringing it into the real world, and fundamentally you're talking about utility at 4.0 level. So making it real and applicable. Let's talk about that then, though, in the context of enterprise. One of the things that Lehman has explained is that the original premise for the Hashgraph was enterprise solutions. And let's talk about that really specifically with regard to permission as well.
Yeah, I'm really glad you brought that up, because that's such a big part of our company's history. It's actually how I found the project. A lot of people in this space, and I don't mean to call out names, do it a different way, Brad. They release these white papers. There's no real tech, and they'll raise $1 billion on a white paper.
More sometimes.
Yeah, and it's staggering. I think it's inappropriate, and I think it's irresponsible. And we've taken a completely different approach. We're bootstrappers. What we've done is we had this algorithm, we turned it into software, and we took that software, we took that SDK to enterprises for validation. And we got a lot of validation. The first big deployment at scale is a group called CU Ledger, which is a credit union service organization that serves the credit union industry here in North America, represented by more than 6,000 member organizations. More than 105 million Americans use a credit union in North America. What they're using Hashgraph for is to build a permissioned network, a permission platform, on top of which they're deploying arbitrary business applications like fraud monitoring tools, messaging services, essentially an app store for any credit union part of this, or any developer group part of a credit union, to build applications that serve the credit union industry at large here. So this is a really big deal for us. They pulled a very senior EVP of payments out of MasterCard named John Ainsworth to be their CEO. They capitalized this organization. They're rolling out as we speak right now. So this is already being deployed, and we're really excited to be part of it. A bunch of members from our team are actually out in Denver working with them later this month. And I think you're going to see a whole suite of robust applications that address things like cross-border international payments, identity applications. So that was one really big win for us. And with that validation, we saw demand only increase from there. And now we work with companies ranging in size from startups that are bootstrapped to the global 500 and beyond, some of the largest banks and some of the largest titans of industry, you could say. And this is really in our permission business. And our model there, our philosophy today is, just like every company runs a web server or a database, our philosophy is that every company in the future is going to run a consensus server. And it may be a consensus server that's attached to a public network, but the level of comfort for some of these organizations is certainly, just like there's public cloud and private cloud, there will be permission networks and there will be public networks. And we're already seeing that take place. So we really have a product for both.
with respect to that, Jordan, as well, we hear a lot of backlash from the community with the ideals that originally emerged with the premise and the white paper of Bitcoin. We see those who want to circumvent authorities, circumvent some of the key functions we see in traditional marketplaces. But what I'm hearing from you is more of the duality, more of acceptance of both worlds, of the permission and the permissionless, and also a realistic perspective. So, is it your position that the coupling of the two is an imperative?
So I really think I think both are going to be great for the ecosystem at large. Let me give you a use case where you need both. Mm-hmm. There's going to be some use cases where a bank, let's say Bank of America here in the United States, might run a permission network between all their retail branches, right? That every retail branch is a node on the network. They have this permission network that keeps the bank balances. But when they want to settle a payment with, let's say ANZ over in Australia, okay, you're not going to be able to settle the payment between this permission network and the ANZ permission network, mm-hmm. right? So when you take that, I did Z. That's weird for me. I normally say Z.
That's all right.
But you would need a public network. So what we're seeing is the formation of these private to public use cases, and it's not just in the financial services industry. I'm seeing it in the telco space. Mm-hmm. Let's say that a China Mobile customer is down here in New York, and they're roaming on the let's say Verizon wireless network.
Right.
That China Mobile organization may have a permission network where they're managing how much you've been talking. This is in their permission. They're in their permission databases, but they need to settle the payment for using part of Verizon Wireless, Verizon's network, while that user is roaming here in the United States. Mm-hmm. And there's a service level agreement in place. Executing that still requires a public network to execute those microtransactions or those payments for use of those networks. So those are just two examples that we're really starting to see form. There's thousands of use cases for mm-hmm. private to public settlement. So I'm excited about a future where I wouldn't even call it interoperability, where there's just connectivity between enterprise permission networks where they still control and own their data, and it's their right to do that. But there's these public networks that help them transact and settle among their peer organizations.
I see, and thanks for that clear example as well, or the two examples you provided. And obviously right now, as we see the emerging blockchains that are coming along with you for the ride, we're seeing a lot of them actually do the dual design of having the permission aspect. So it makes perfect sense, and certainly you are well situated, let's say, in the current climate. Let's talk about now your platform key areas. You have 4 that are articulated well in your white paper and certainly in your website. The first one is performance. If you could just give us a bit of a recap on what makes you so performant as an algorithm.
Yeah, so I would say that it's because fundamentally there may be others that claim to do what we do, but they will never do better. You fundamentally cannot do better than what Dr. Leemon-Baird has invented here. We should talk about Leemon for a second. This is a guy that in 1993 was working for the senior scientists on machine learning in the United States Air Force. Okay. What they effectively did was they built the missile defense system, a missile defense simulation. It's parodied in the movie War Games. But what this is it simulates intercontinental ballistic missiles being fired at the United States and her allies, right, and how we would intercept these missiles and defend our territory. With that, these guys ended up starting 2 companies in the identity space. One was acquired by Fortune 500, the other by a very large private equity firm, mm-hmm. and they've been working together for more than 25 years. Leemon-Baird and Mance Harmon. Yep. Leemon's notable in that he set the record in the fastest PhD from Carnegie Mellon University in 2 years, in 9 months. For anyone listening that has a PhD, I think that's remarkable. That's faster than an undergraduate degree.
It's amazing.
And he's really one of those once in a generation kind of minds that he's really done it this time. And I'm going to make some bold statements. I'll make one right now. But I fundamentally believe that this is the kind of breakthrough that wins someone the Turing Award,
right?
Which is really the Nobel Prize in computer science. So I'll start with that, and then when I answer your question on performance, you'll understand that this has never been done like this before. What you're seeing in the marketplace is these solutions, these side chain scaling solutions, things like Lightning or Plasma. We don't need to make those compromises. What we do instead is we do it native. We do it on the graph, on the hash graph. We don't sacrifice security. We have ABFT for this throughput, and we're achieving more than 500 million transactions per second with very little consensus latency, about a little over 3.5 seconds of consensus latency. And we didn't stop there. We're actually able to still use a GPU to do digital signature verification. So we're running these digital signatures through a GPU, and we're able to achieve more than 1.18 million digital signatures per second. Okay, so every second, 1.18 million. This is the most performant consensus algorithm on the planet today.
It really is. I mean, obviously, I'm fortunate to speak to many CEOs who represent many blockchain initiatives. And right now, I can tell you that the common thread we hear, or the common number, is 10,000 if we're lucky. In fact, it's more like 1,000 TPS. So once again, you know, to have that already functioning, not to be a theoretical possibility, given your premise in the enterprise space, is quite significant. And then couple that with the experience you have of Lehman, it's setting you apart. It just simply is.
And that means a whole lot coming from you, Brad. So I appreciate you saying that. I would say that the tests are real. They're in our white paper, and you can reproduce them, right? You have the ability to take our SDK, run this in AWS nodes, and reproduce those results. And we've never had someone come back disappointed. The question really is we have to rethink our entire strategy, because we were trying to come up with, this is coming from enterprises, we were trying to come up with use cases that fit this blockchain box, right? A lot of times you see enterprises, okay, so we'll have 7 to 12 transactions per second, or maybe 1,000 that Coco does. What are some business processes that fit here? And it's not a whole lot. And that's why they're not deploying. When you open it up to the possibilities are limitless, then we start to see some exciting applications.
Right. And what's also exciting as well is you have near perfect efficiency with your bandwidth, and you also have outstanding finality as well with your design.
Yeah, that's exactly right. You get it's completely deterministic. It's not probabilistic.
Right.
With a lot of blockchain systems today, you can be 99% sure that this is the state of consensus. And with every additional confirmation, you become more sure, but you're never absolutely sure. And Hashgraph gives complete finality, as you mentioned. It's completely deterministic. You're guaranteed consensus.
And that is a fundamental difference between you and the original iterations of even the Bitcoin white paper, being a probabilistic design. And I think that's important.
Exactly right.
Let's talk about now your democracy aspect. You know, you argue it's fairness. It's very exciting and fundamental with your timestamps.
Yeah, I think it's a really important point. So this is the fairness property. Let's first talk about the what are you trying to solve for? You're trying to enable people to do things that fundamentally you can't do in other systems because there isn't fairness. So what those are auctions, they're stock markets, matching platforms, right? How does a bid and an ask get matched? Or if you wanted to talk about it from the perspective of an ad tech use case, where you have a publisher that has this ad inventory and you have people bidding on that, how do you decide who gets it? Right. So with all of this, how do you achieve that? What you do is, we don't trust each other, right? It's a distributed system. So you can't trust an individual's timestamp.
Right.
Instead, what you do is you take the median timestamp. So there may be outliers, people lying, bad actors saying that's this timestamp. But if you take the middle, if you solve for the middle, the median community timestamp of when most people received it, and you trace it all the way back, you follow it, you come to the middle, what you're able to find is that you can get a fair timestamp of when most people in the network receive this particular transaction. And that's the most fair way of doing things.
Right.
It really is. Now, of course, Brad, if you have faster bandwidth than I have, right? Just like in the world today, if this bank down the block from me has a faster connection to the stock market, their trades are going to get executed faster. If you have faster bandwidth to the network than I have, your transactions are going to get executed before mine.
Right.
But that's still fair, right? If I'm on an edge network and you're on 4G or 5G, right, you're going to have your trades or your transactions processed before mine.
Exactly. Well, let's talk about now honesty with regard to the design. What is interesting is that being democratic, you also have an element of trust built in. But in doing so, with the bad actors you've referred to, there is a potential with every design like this for there to be too many. And in the instance where you have more than a third bad actors, which is very unlikely, but it is possible, what could that do to your network?
Yeah, so let me address how we're preventing what you're just saying from happening and why I don't think it will ever happen.
Okay.
And in a permission network, permission and public networks are very different. And there's in a permission network, you would know all the nodes in the network. You would know your population, your N or your P. You could call it the number of nodes. In a public network, you're going to have the dynamic adding and dropping off of nodes over time, where that's a variable number. What you're really doing is you're solving for, in a permission network, it's one node, one vote. Every node in that network can submit a vote. In a public network, you can't do that. And the reason you can't do that is you'd be vulnerable to something called a Sybil attack. And a Sybil attack is when a bad actor can take 100,000 nodes, put it on the network, and overwhelm consensus. By the way, spinning up VPSs for 100,000 nodes sounds like a big number, but it's become economically easier to do. You can go to DigitalOcean. You can very easily do this. And not encouraging anyone to do this. But what we end up doing is we do one coin, one vote. Mm-hmm. So it's a proof of stake model. And what you're then doing is you're protecting the coin supply. So the Hedera Hashgraph network on day zero, on launch day, will not have more than a very small amount of coins in supply. It will actually be less than 10% of the entire coin supply. Right. What we have is a governance body that ensures that the rest of the supply, and there's no element of centralization here either, it's a governance body of 39 of these trusted, mainstream, blue chip, multi-billion-dollar multinational companies that trickle the supply out into the marketplace. It's not me or Lehman or Mance. There's no central person making that decision. Instead, it's this distributed board of governors that trickle that out. In over 5 years, there will be probably at the 5th year mark, you will start to cross that threshold where at that stage, more than a third of the coins would be in circulation. What happens between 0 and 5 years is really important. Right. The price of the coin would make it economically difficult for any bad actor to consolidate all the coins in the world. You would need a budget or of a very large nation's GDP to be able to go consolidate that, and that would make it very difficult. So long as 1/3 plus one of the coins are not held by a bad actor, the network is still ABFT, will still achieve consensus, and you're not going to have any problems.
I see, and most importantly, you've made it very difficult for that to ever happen, if ever it could. It sounds like it can't. Let's move across now. Exactly. Let's move across now to your security. It's extremely important, given that you are asynchronous by design. You argue that you have the strongest proven security system. And again, once again, you've also explained that you can prevent yourself from having those DDoS attacks.
Absolutely. And more than just DDoS, I would say it's Hashgraph is resilient to attacks that others don't consider. I could dive into depth on this, but I wouldn't do this topic justice like Lehman would. So while I'll broach the subject, I will tell you that what we've seen happen here is we've seen these Lehman gave a talk at UC Berkeley, at Blockchain at Berkeley, where he addressed most of the major attacks in the marketplace. And why Hashgraph is resilient there. That's a talk I'm referring to, and I'll share that link. What we've done, again, is we've started with that 30-year-old academic definition of ABFT, and as the network scales, we preserve that ABFT property. So, yes, it's DDoS resilient. Yes, we're resilient to Sybil attacks because of how we're controlling the coin supply. I fundamentally, just as a starting base, we don't make a compromise by making up a new term to justify the security compromises that we've made. We haven't had to do that. This is why Hashgraph is a breakthrough. We are ABFT by that 30-year-old academic definition, and I don't think anyone else can say that.
Sure. Well, let's talk about now your final element, the fourth quadrant, and that is relating to the how with regard to your gossip protocol. You know, the compounding nature of the node to node and how it evolves and is very robust and very fast. Just why is this gossip about gossip so important with your voting system?
Yeah, so so gossip protocol exists today. It exists in Bitcoin. It exists in other systems. What we do that's unique is we have gossip about gossip. So what you're actually doing is while Alice is offline, Bob, Carol, and Dave are gossiping with each other about all the other transactions that have been happening on the network. And when Alice rejoins that network, she'll have a quick sync event with another node at random. She won't know who, and it will be at random. And she'll get informed. There's an economic incentive, obviously, for the other nodes to inform her of the transactions that she missed based on the sync. What are the local copies of transactions she has in her database? What has she missed? She'll get synced. What's interesting is she only needs to be caught up from everything since the digitally signed state of consensus, the community consensus that she has, and that what, let's say, Bob has if she's syncing with Bob. Right. So she's quickly informed. This gossip about gossip really enables incredible throughput. What we're doing is we are pruning the hash graph below the last signed state of digital consensus. So when you look at it, you're talking about you have a digitally signed state of consensus. We can prune everything that happened before then because the whole community agrees that we all have this baseline now, and everything before this is no longer needed. You can store it if you'd like, and we still have the immutable audit trail. Many nodes are still storing that, and we still have that. You know every transaction from the beginning of time. Right. And
just in that reference, it's also storable. If someone wanted to go and store that offline, they certainly could.
Yeah. Absolutely. You can remotely store that. You store that offline. You can call that up through API calls. Our Hedera has a a distributed file store. You could store that in the distributed file store and still run your Block Explorer or your Etherscan, right? And be able to check the transaction and be able to check every transaction from the beginning of time. That all still exists, right? That's not going anywhere. You just don't need to send that to everybody. Not everybody needs to have that all the time. We just need the digital signed state of consensus. So, and I think that's really important. What's really being sent, just to hit this point home, because I think it's an important one, you're literally sending 2 additional bytes of information. So in an event, let's take it like a circle. Sure. In this circle, if we zoom into this circle, and there's a really great graphic of this on our website. But what's in it is a timestamp, okay, which is not your timestamp. It's that median consensus timestamp on when most people receive the transaction. There's an arbitrary transactional payload, and that's just based on the application. If it's a cryptocurrency, it's 100 bytes, right? But if it's a game, there may be that may be larger. Right. But if it's a cryptocurrency, it's 100 bytes. And then there's 2 hashes. And those 2 hashes are the digital signature of the last transaction, your local copy of the Hashgraph, your local copy of the database, and the last transaction you received from another node on the network. And by having this, again, what we're building this unique data structure that has never before existed, where we have this beautiful picture. And when you watch it form in real time, it's really quite a piece of art. It's who's talked to who and when. Right. And it just if you picture these 4 lines in the network, Alice, Bob, Carol, and Dave, there's just these circles, which are these events with these lines connecting them. And as new nodes join the network, it increases horizontally. And what you're doing is people are just rapid fire. You're sending transactions, and this is how we're able to achieve more than 500,000 transactions per second. Right. And by the way, Brad, it's important to point out that's in a single shard. Yes. That's in one shard. What we have is we have a sharded scaling proposal where when we scale, our intershard protocol retains its ABFT building block. We don't sacrifice security. It's a node in one shard at random because we don't trust another shard. It's randomly picking another node in another shard and syncing up and gossiping with each other. And we're able to, if we're doing that in one shard across the entire network, be able to achieve millions, possibly hundreds of millions, maybe even one day billions of TPS.
And so you're really removing the question from the equation of whether or not we can achieve the TPS required. And we're going to talk about that now, actually. It was part of a later discussion. But with regard to Visa, let's talk about the theory that underpins Visa. And that's important for what really precipitated some of the work that you did, or well, that your team have done.
Yeah, that's. I'm really glad you brought that up. So I have the book here somewhere, and it's a great book. This was our starting point. And the starting point, we weren't the first to struggle with this idea of how do you build cooperation among organizations that may very well be competitors, right? How would you get a let's say an insurance company in Australia to work collaboratively with a stock market, a market maker in America?
Right.
And as it turns out, there's this gentleman named D. Hawk. D. Hawk is the founder of Visa, and back in the 1960s, he grappled with the same set of problems. And in a book called One from Many, which is about the rise of chaotic organizations, he talks about building this collaborative, cooperative organization where the output is a high tide that raises all ships, right? It's to the mutual benefit of all of these competing organizations to lay the framework for the Visa network.
Right.
And that's what we've seen happen at Visa. The Hedera Hashgraph Council started with that as the starting. So my point, Brad, is there's precedent for this. And what we've done is we've taken the Visa model and we've decided to build this, we call it the Hedera Hashgraph Council. And what it is literally is it's this consortium or council of organizations that don't trust each other and don't have to. And the reason they don't have to is they're not like each other. They're so unique, each and every one of them. They're best in their respective industries and best in their respective classes. On planet Earth, there's probably, you could safely outline about 18 different industry verticals, from retail to insurance to shipping and logistics to banking to personal electronics manufacturers to FMCG, fast moving consumer goods. So all what we've done is we've taken the best in class from each of these industries. This has been a very long process, and we've been working on this for quite some time.
Right.
And we've taken these organizations that are also geo-distributed. So we have organizations actually in Australia. We have organizations in Singapore. We have organizations in Europe, in North America. We're really global, and many of them have actually already stood up nodes on our test network. And what we've done is we've built this global body of governors that, one, don't trust each other and don't have to, but the mainstream can trust them, because the odds of an electronics manufacturer in Seoul, let's say, being part of or colluding with a bank in Australia is very unrealistic, and it's not going to happen. It's not going to happen with these 39. Additionally, they have an economic incentive to instill the trust of the mainstream. And this is why we have geo-distribution across the globe, and we have distribution across every major industry sector. It's also important to note that it's not a lifetime position. It's actually term limited. So membership on the Hashgraph, on the Hedera Hashgraph Council is set by 2 3-year terms, consecutive terms, and then they'll have to leave. They'll go for a while to prevent stagnation. And if they get invited back or welcome back, the membership would decide that. So we don't decide the membership. The members would decide who leaves, who comes. If a company goes bankrupt, their seat does not pass on to their acquirer. It goes to another organization. And this is how we're building a living, breathing, chaotic organization that will instill the monetary policy and pull the levers that we're familiar with central bankers pulling or a Federal Reserve chair pulling. But instead, you don't really trust them. At least the mainstream's not trusting them as much as they'll trust this board.
And with regard to that, Jordan, let's get real with this. You have 39 entities, commercial entities, arguably, that are representing this government structure. You could liken that to any government for any nation. You could even say it's like a Senate. But what is interesting about this is that people could argue that this is a centralized mechanism for a decentralized model. What would you say to that if someone, tried to present that to you?
So I think that'd be a very small-minded view. What we've actually achieved here is open consensus, where literally anybody, including a single mom in Vancouver, Canada, could throw a node on the network and make enough money to make her car payment or her mortgage payment even, and participate in open consensus where she's making money by gossiping about gossip on the Hedera public network. But what we've done is we've created permission governance. So that single mom probably does not have, and I don't mean to single her out, perhaps she's very highly educated, but what she doesn't have is at her disposal is the resources that a multi-billion-dollar multinational company has to be able to contribute expertise to a technical steering committee or to a legal committee. And what we do is we form an organization that's completely open consensus, where we will have millions of nodes gossiping about gossip on the network, perhaps even one day billions. Right? And especially when we have IoT nodes, we do all of our testing as a special node on Raspberry Pi devices, which I think is unique. But to answer your question directly, it's permission governance because this is a familiar model that instills the trust of the mainstream and also simultaneously now allows mission critical organizations like power plants, utility companies, even governments to deploy distributed applications on a platform that is still distributed. So there really is nothing centralized about that process. The membership decision is not centralized. The members decide. We ourselves are simply one of the 39. Swirlds is one of the 39. That is the relationship between the two organizations. But the Hedera Hashgraph Council is a member-owned, member-operated organization. And you can't you really, one, Brad, this doesn't exist in the marketplace today. And two, it simultaneously addresses all the problems in the market. And I'm starting to do this a bit of a monologue here, but I think this point's really important. Let's really get honest about what's happening in the public.
I mean, I agree, because I think it's so important that we also address this issue of agenda, because no doubt the structure and the model in place is designed to be fundamentally for the people. It's meant to be for the public ledger that you are designing. But when you have 39 members who are fundamentally enterprise governed or motivated by their own interests, the question must be posed about the agenda of those organizations.
Well, Brad, let's talk about the people, right? Because this is really important. Let's talk about the people at large, because they're the most important people here. They're disgruntled. What we've seen happen after the 2008 financial crisis that then led the world into this global recession, people felt that their hard-earned dollars or pounds or was infringed upon, where we have these central banks that just print money. That will not happen on the Hedera Hashgraph Council. But more importantly, you have chaos in the public crypto marketplaces today, and no one's saying it, and we need to say it. Brad, it's chaotic out there. Anyone, me, you, and a couple of our buddies can get together, and this weekend we can go fork Bitcoin, right? Pablo Escobar's brother, I just saw a news story. Pablo Escobar's brother is making a fork of Bitcoin called Diet Bitcoin.
You're absolutely right. It's very easy to do.
Professor Fastos, Craig Wright is claiming to be Satoshi Nakamoto. It's insane. Today, we have 3 different flavors of Bitcoin. There's probably going to be 6, 7, or 8 in 2018 alone. And the economic incentive is to fork the chain, because if we fork the chain, we become billionaires, possibly, right? That's crazy. So what you end up happening, and this is really controversial, and people hate when I say this, and half of the people in the room walk out or roll their eyes, but I'm going to say it because it's important and it's the truth. And that's why it's hard to hear, and that's why it's not popular.
Bring it on.
But
Let's go.
What needs to be said is that open source fundamentally is a great concept. In an open source development community, if you're a developer and I'm a developer, we all contribute our best code to an open source project. But when you combine it with a cryptocurrency, it puts the incentives on their head, and the economic incentive is to fork the chain. And this is why you have this volatility. This is why you're having chaos. No one is going to deploy mission critical applications on a network that can be forked, period. No one is going to deploy mission critical applications on a network that could possibly that is just going to have this volatility, or that's run by a benevolent dictator. So this is where we are today.
And Jordan, we're seeing the evidence of that with governments. We're seeing the evidence of that with enterprise. Right now,
Yep.
we're literally having institutional investors or institutional money waiting to utilize the blockchain, and only when this is being addressed by companies like you are they even considering it. Simply because why would anyone invest in a company that can essentially become 2, 3, and 4 and not know its viability, and certainly completely alter from its original precepts?
Absolutely, and this is why it's got to be said. It needs to be addressed, and we're doing that. We're doing that in the marketplace.
Perfect segue into this, and that is your unforkable nature. It has to be addressed. You are not forkable.
That's absolutely right. So Hashgraph consensus is patented. We have patents in the United States. They're not pending. They're granted. We defend them globally, and the Council of 39 has the economic incentive to defend those patents. So we defend it with the patents. We also defend it in a different way. When we want to upgrade our wallets, we gossip the upgrade out that at this date, at this time, everyone's going to upgrade their wallets.
Right.
And that's a compulsory upgrade, right?
Right.
So with that, you end up creating something. And by the way, I want to make a really important point here. It's important to note that we have complete transparency into the code base. You have complete transparency into, you're not making API calls against a black box. Mm-hmm. What we're actually doing is we're releasing the code base with version 1. Right. Everyone will see the code, but you don't have open license to that code. In a permission setting, if you want to deploy it, we have an organization called Swirlds, where our revenue model in full transparency is to license that consensus model to organizations to go and deploy these networks.
Right.
And on the public side, the incentive is for these organizations is to create stability. That's why they're multi-billion-dollar multinationals. That's why they issue this monetary policy. That's why they have this technical roadmap, and that's why they're going to prevent the network from forking. We guarantee the Hedera network will not fork.
Right, and we appreciate that because of the reasons we've discussed. We can access your code. No doubt, if someone wants to go and find even in a GitHub sense, they could go and unpack what you're doing.
Yep. See the entire code base. Yep.
So full disclosure.
Full transparency. You see the code. You can trust the code. The code is audited by the community. There's even code bounties where if you see a bug, there's a bounty for it.
Right. Well, let's talk about now swirls. Sorry, my apologies. Swirlds. Difficult pronunciation, but very important platform. And one of the things I want to clarify with you is, you know, there's many statements in the presentations about the Hashgraph platform, but is it in fact true that the Hashgraph platform is actually the Swirlds platform? Or if not, what's the difference?
So Hedera Hashgraph is Hashgraph. So it is Hashgraph consensus. So as a starting point, that is, it's one and the same. It's the same algorithm. I think that's really important. The services layer, that's one layer above the consensus algorithm, at Hedera is a bit different because we have a wallet with an associated cryptocurrency that's there for network security and for microtransactions. We have a distributed file store, and we have smart contracts where you can literally do your ICO or just execute an ERC20 on top of what we've done with smart contracts is Solidity. So the foundation is the same. They may have different services layers. And at Swirlds, we're actually very tech agnostic. What we've done at Swirlds to really be tech agnostic is we're actually building pluggability into the other major software development kits. So into Hyperledger and into Corda and into some of these other platforms. Swirlds is the inventor of the consensus algorithm. It's our enterprise business. Mm-hmm. Swirlds has given license to the patents, to the right to do the only official sanctioned public ledger of Hashgraph is to the Hedera Hashgraph Council. Mm-hmm. Swirlds is one of the 39 on that council. On par, no more power, no less power than any of the 39. And that's the relationship. There's a license agreement between the two where Swirlds is paid a very small percentage, something like 10% for use of the patent. And those are the commercials. That's the relationship. They're two separate entities. Hedera Hashgraph is not a subsidiary. It is a separate, living, breathing, chaotic organization that's member-owned and controlled. Swirlds is owned by Dr. Lehman Baird and Mance Harmon. And there's some notable investors in that organization, but it's a separate enterprise business.
If we could talk about the development aspect, you've made it clear about the governance, but developers themselves are very key to building out the robustness of your design, fundamental. So what, in a sense, what are you incentivizing, or how are you incentivizing developers to utilize your platform?
Yeah, so what we've done is we've decided to take our approach to the market is that you don't have business guys like myself talking to developers. Developers want to talk to other devs, right? They want to talk to devs, just want cut the bullshit, like show me the code, right? And what we've done is we've built a program of developer advocacy. So we hire devs in our business development department, which is really unique. A lot of other groups don't do this. Our devs write code. They're experts in the Hashgraph software development kit. They sit in our community. They troubleshoot questions. And what they're doing is they're building a set of self-serving tools that anyone can use, including a certification program to become a Hashgraph certified developer for the Hedera platform. They're building sets of documentation and videos and resources for people to really leverage the network. And I think this is really a unique approach to the marketplace. This has won over a ton of fans. We have more than 3,000 developers in our ecosystem today between our Telegram and Discord communities. And the number is growing at a staggering pace. We have more than 20,000 downloads of our SDK where people are looking at the code and deploying it. And the ecosystem is booming. We are also taking the Hedera services layer to hackathons beginning in April and May. So we will be April, May, June on the road doing many hackathons. We did one last September with this World's SDK just as a trial, and we were blown away by some of the stuff that people built. Someone built a game in less than 24 hours called Kitten Catch. Someone built a Hashgraph fair auction ledger, so like a distributed Christie's or Sotheby's or even an eBay, which is incredible. There's some remarkable applications that people just get so creative. Keep in mind, this is 24 hours, very little sleep, pizza beer party at midnight, and you're in a cold convention center, right? And this is what people were building. So it's real. It's real. You can touch it. You can play with it. They get on stage and they demo it, and then we give out prizes. We gave out a $5,000 prize last September, and we'll be doing that. So that is what we're doing for the ecosystem. Additionally, and I want to make this point, we're having these new groups form where a really great fund called Mind Fund by a guy named Adam and Mark Chang out in Hong Kong. They have the largest AI incubator in all of Asia based in Hong Kong. What they're doing is they're spinning out a new organization where they're incubating a class of 10 new distributed applications. And actually, anyone listening to this, I'll try to dig up the link and your listeners can apply. There's a global grant for 10 people to build Hedera-specific distributed applications, and they're funding them to the tune of close to $100,000 US per project. And you'll go, you'll get trained, you'll go be incubated with their incubator in Hong Kong. And I think that's incredible. The ecosystem is really flourishing. That's not us. Right? That's their incubator that they're investing in projects because they've recognized the power of this technology.
And this is only 2018, so we can only imagine the growth factor of the dApps that can be potentiated and utilized on your design. Clearly, you're optimistic about the future. Let's talk about that for a moment. You foresee, no doubt, serious growth in the context of the next few years.
Yeah, I foresee. Again, let's talk about where we came from. Everything up until this point in time on the web has been too centralized. Facebook is in the news right now.
Yes, I saw.
Infringing on our privacy rights and not protecting our data. This is just the beginning. You can really call them the four horsemen, but Apple, Google, Amazon, this is just beginning, Brad. It's going to trickle up. The world is moving. We move from data centers to the cloud. And, I was having a conversation with the guy from a bank. I won't call him out or his bank. But 10 years ago, they said, we swear we will never use the cloud. Today, more than 85% of their infrastructure is cloud-based. Right. They use AWS. It's great. No one thought we'd move from data centers to cloud. What we're seeing now is a tectonic shift from cloud to distributed cloud, the peer-to-peer cloud. So at the beginning of this interview, you mentioned that Hedera Hashgraph, we call ourselves the trust layer to the internet. Right. Internet, the peer-to-peer trust layer. What we mean by trust layer is the peer-to-peer transactional trust layer that sits on top of the internet. And what you can accomplish by doing this is you build a fairer, faster, more secure world where not only do you own your data, but you can see its digital footprint and you know what someone did with it. every bit of food, whether this tea I'm drinking, this Bigelow tea, I could track the provenance of this tea across the entire supply chain. My vitamins, or if I had a prescription pill, I'm not on one right now, but if I did have one, it would have a barcode on it that when I scan it, it's attached to a smart contract where I can verify the provenance of that pill across the entire supply chain.
Right.
And much more. MMORPGs are played with fairness. It's not that you have a lower ping or you're using a VPN, you have a better connection to the data center. It's that it's a provable definition of fairness that we're playing an MMORPG and you pulled the trigger or clicked before I clicked and you killed me before I killed you and you won, right? A fairer, faster, more secure world. This has ramifications globally with use cases we haven't even begun to consider. I see trillions of dollars of value pouring onto public networks, and I see a very bright future where I think that the challenge for mankind, for us, is to stop thinking in centralized terms and to start to think in these chaotic terms like D-Hawk was thinking in back in the 1960s. And I want to live in that world. I want my son to live in that world. And I'm really excited to be one small part of it.
And honestly, Jordan, you are part of that. You are part of that process, and you're part of the movement to create that. And you're certainly leading the way from at the very least, from the literature and from what you're doing at the grassroots. And let's move across now to your tokenomics. Let's talk about ICOs. Let's talk about directly your ICO and your token. What's happening there? What is the plan exactly?
Yeah, it's a great question. So we're not yet publicly talking about our let's say our fundraising efforts. There have been a few small private rounds that have gone just to capitalize the company and be able to pay for getting the product out and getting it refined enough to get to market. And now that our tech is really there and we're already in testnet phase, we'll be sharing much more on this publicly. At this stage, I would say that if there's anyone interested, this is not a solicitation, but they can go to our website and they can register their interest. And when we're able to share more information, we'll simply send company updates regarding that to the people on that list.
So let's talk about that in the context of previous ICOs we've seen. Obviously, even now, the term itself, given the SEC, is something where many companies in the US are reticent to even use. So with that respect, what we're suggesting, or what I'm seeing from you as an example, is that there's a transitioning happening now in the approach taken to generating funds and trying to engage with the wider community and how they participate.
Yeah, I think I think internet access is a human right, and I'll take it a step further. I think access to a distributed network like Hedera should be available to all. And we are putting our money where our mouth is and coming up with creative ways to achieve that within the confines of the law. So we are a US-based company. We work with many law firms here to help navigate these waters, and certainly the regulators have not made it easy to do so. But we feel we have many creative ways to get developers on and building on the network early, and they will be among the first to have access to it. And we believe the public at large, not as a means of speculation, but as a means of actually using our services, actually using native microtransactions, which have implications if you have Philips Hue light bulbs, or if you want your washing machine and your Bosch and you want it to talk to the wireless router and send you a text message when your laundry's done, right? All of these things can now be done, and they haven't been able to be done before. And we want the entire world to have access to it. How we practically do that, as it was a really great foresight on your part to know that things are moving very quickly and, of course, shifting from how they were done previously. But we're doing it, of course, to protect the end consumer. We're not doing this for speculators, but we do think that there's a great opportunity to get everyone on the planet involved. And I don't think it will be long before we achieve that.
I see. So you're doing it for equitable reasons. Can we talk about, though, with regard to the tokenomics of your design? Clearly, they're finite. So in terms of tokens, how many do you have, and what is the amount that you've kept for your own, governance and your own control?
So the governance actually controls the supply. The governors themselves have the option, but no mandate to own coins. Many of them have they don't know how to put it in their accounting software. These are billion-dollar companies with legacy systems. They don't even know how to account for, how they would register a Hashgraph coin in their system. Okay. So many of them don't even want to touch it. Instead, what they do is they just make decisions that benefit because they have a value proposition and that they make money when the coin, so it's a for-profit organization. And the Hedera Council actually sells services. We sell microtransactions. We sell distributed file storage. We sell the execution of smart contracts. You have to pay for that. And the members make money by making sure those services are evangelized and used globally and are readily available to all. So they have an incentive to protect that supply and obviously to keep the network there. There is a fixed supply. It is it has not been set, which is why I don't want to give you a number, but we'll happily share the number once it's been set. We've moved it because we started with a very small supply, and then we got a lot of complaint about IoT and having the need for the perception to be far greater quantity of coins. So that's still moving, but I can tell you it's a fixed supply. Okay. And once we share what that supply is, it will not change from that point. Right. So no one will be diluted, and that will never be a concern. Regarding what the team and what investors have, there are very strict lockups, which make the project very unattractive for pump and dumpers. Okay,
and that's what we want to hear, to be honest, because there's so much of it going on.
Yeah, so what we end up having is, me, Mance, Lehman, the rest of the team, we're locked up to the tune of 5 to 6 years. At Hedera, we are legitimately building the foundation for what will become a 100-year company. And to talk about Lehman, right? I just talked about myself, but talk about Lehman. Lehman's probably one of the most, for those who have been fortunate enough to meet him or hear him talk, he's one of the most humble guys on the planet. And that guy is probably going to drive a Toyota Corolla and live in a 1-bedroom apartment for the rest of his life. And that's really a testament to who he is and who even Mance Harmon, our CEO. These are incredible thought leaders, but at the end of the day, the most genuine family-oriented people. One, that's really our company culture. It was one of my first weeks on the job, and Mance had actually sent me a text. Listen, you have a young son. Get offline and stop sending me emails. It's Saturday. Spend some time with your kid. Yeah. And that means the world to me because we're not sprinting. We're not sprinting to get rich quick overnight. We're building, and frankly, I think many of us are just going to give it away, right? There's this great giving pledge that guys like Buffett and Gates have really led by example with, but the secret to living is really giving. And I don't mean to derail this interview here. No, I understand. I think that our culture and the caliber of people in this organization, what we enjoy is the challenge of waking up every day, solving really hard problems, and building an organization that will stand the test of time. This is going to be morbid, what I'll say next.
And I really appreciate that.
If I'm dead in a ditch tomorrow, I'm really all not that important, and I'm putting the systems and processes in place so that the business will even outlive me. Right. Because what I'm really after is legacy. Right. That's the only thing you'll keep. No one needs to be the richest guy in the cemetery. What we're really after is building something great that will fundamentally change the way humans interact with each other and interact with the internet. And that's why we need this trust layer.
I see. So essentially you want to be part of the transformative technological, movement that is the, what we're seeing now for applications, for people in general, which is it's a really inspiring thing to see that you're part of this team. And let's talk about now, industry in itself. If we could talk about some specifics, and that is with regard to partners. It's something we haven't talked about yet. We know that there are 39. I'm not sure how much you can disclose of these, or even if they are published. But just how big are these organizations? They surely must be
they're giants.
Well, give us some names.
So today I cannot share names because
you really can. It just requires you to tell me. Working with these organizations is really unique. It's been one of my favorite challenges that I've had the privilege of having in my short career thus far, which has been brokering between these organizations, just getting the right to use their names from their legal departments and their risk and oversight teams is a tremendous process. Right. What I can say is I can really allude to really the caliber of who they are. We have one of the largest banks in Australia, one of the really premier, you know their name. And I already know who they are. I'm sure I'm going to find out exactly. But the point I think is that I respect the fact you can't disclose them. But can I ask you why? Why is it the case that you can't yet?
Well, it's not a case that we can't disclose. It's a case that today we're not disclosing them. What we're waiting is for them to finish their activities in terms of coming onto the testnet and scanning their nodes online. And then there will be a separate announcement where the founding members, the initial 10 of that set of 39, will make known who they are to the world.
Well, make sure you invite me to that party. I'd love to see just that, on stage, seeing those 10.
Absolutely, and I think it will be. I think it's going to be something that this distributed ledger. We keep saying blockchain. I know you're BlockchainBrad,
yeah,
but
right.
we're gonna have to call you distributed ledger technology.
That's right.
Because I think this will be one of the biggest splashes in the DLT space at large. Probably even one of the bigger things since Satoshi's white paper, just because the players of this size and what is now possible just hasn't been done up until now, and we're doing it, and it's real.
Cool. It sounds amazing. So let's talk about now the number of dApps as well, without trying to inject too much hype into this conversation. I certainly don't like to, but already there's some dApps emerging, some projects that are going to utilize your platform. So in terms of 2018, how's it looking?
So it's looking way better than anyone could have possibly expected, especially since the Hedera services layer has not been released to the public.
Okay.
When we release that to the public, we anticipate being inundated with inbound interest, largely because we're able to run Solidity scripts. So we anticipate almost every Solidity development team to be able to run those scripts without any throughut restraint.
And that's a huge
to be able
market.
to use that.
That's a huge market in itself.
It's massive, and it's going to further blow up our development community. What we're seeing today is, one, we're seeing a lot of inbound interest from ICOs, really great teams. I have nothing critical to say about these guys. They're coming in, they're great. They need to capitalize their organizations. So what they're doing is they're doing these coin offerings, and they're going to use the ERC20 standard, but they're planning on distributing that on the Hedera platform. And I think that's really unique. So it's the same standard that everyone's familiar with over at the Ethereum mainnet, but instead they're going to do it on the Hedera mainnet to be able to not be bottlenecked, let's say, with their transaction times. And we all know about the CryptoKitties disaster when they sucked 30.
Crazy.
Exactly. So what we're seeing is a lot of interest from those teams, and we welcome all Solidity developers globally to come test it, try it out, and we think it's going to be exciting. That will be in April, where we'll first let the first couple of partners in. In terms of number, I can't speak to the number. I can tell you I would speak to the caliber, and then the number is, I'm not going to count all the little guys that aren't capitalized yet. That number could be in the hundreds in our CRM today, and how we're working. But that's just interest. That's not real. I want to give you something real, and that's why we brought Gabe Layden, the founder and CEO of Machine Zone, which is a multi-billion-dollar company. He was on stage at our launch event. So Satori is a pub sub system that has real customers, and now their lit token, LIT, is one, not only going to be on the platform, but their application actually makes API calls to our platform. And, I could talk about all the little guys. And
I respect that you're not, because obviously we don't have the time. But what I did want to ask you is, are you involved in the vetting process of these to ensure the quality? Because that's really what you're addressing.
Absolutely. I mean, I'm involved in every step of it. I have the unique perspective of, I've been doing these calls for almost a year at this point, where, just when we were Swirlds and we were doing just permissioned businesses, everyone at that stage was calling saying, can I launch a public network with this? Right. And we're like, no, patience, it's coming, just be patient. Well, and now that it's finally here, there's a lot of interest.
And it's very good to hear that you are involved in that process of assessment, because, and I'll say this only in that we've seen with the development of Ethereum, we've seen that with the intentions to really allow for that public access, unvetted, it's caused some serious problems with their own provisions and facilities. It's not only in the bottleneck sense, but also the quality of the actual projects themselves. So you're doing something almost converse to that. You're making sure quality precedes quantity. What is interesting is I've had the fortune already of speaking with one of the projects coming on called Intiva Health, and I can tell you from experience, having spoken with them at length, it is an absolutely outstanding project.
I'm so happy to hear you did that. I did not know you did that. I don't know how you did that, but congratulations on doing that. They are, what they're doing is really a first. I don't think that this exists in the medical space today, at least not that I'm aware of.
I would agree, especially
I've heard, and you have a lot of people talking the talk, but not a lot of people walking the walk. I like that they're doing it. I've heard a lot of people trying to do this, a credential management tool for doctors, nurses, and other healthcare professionals, but I've not actually seen someone build it. And I've actually seen a demo of it. It's incredible, and it's going to be it's going to be game changing, namely to allow the portability of a doctor across jurisdictions, that a doctor licensed or accredited in Singapore can then maybe more easily practice in Malaysia or globally. So doing that, if you're a lawyer, I have so many friends that, grew up in, were born in Pakistan, their families came over, their parents had to redo parts of medical school just because the license or the accreditation didn't transfer over. They couldn't verify it. This is going to be a thing of the past. Yes. And, kudos to those immigrant families here in America. This country is really built on the back of immigrants. And, what they had to go through, blockchain is, DLT is going to solve that.
Right. I'm not going to let you talk too much about that because it'll take away from the quality of an interview. But you are right. You are absolutely right in what you're saying. And you'll see much more. In fact, it's not just doctors. It's going to affect patients. It's actually going to affect the entire economy. So look out for Intiva Health. And thank you to Hashgraph for considering them enough and taking them seriously. Let's move across now to criticisms. You go onto Twitter, you'll go onto Telegram, you'll see criticisms of you, very direct ones, allegations even. Let's just get real. What are the key ones that you've read and heard about that you're trying to debunk and refute right now?
So I think, to address the elephant in the room, there's these binary folks in the development community, and I say binary ones and zeros, but they're really black and white in that it's open source or it's not. Right. And I think that I love open source projects. My entire previous company, my VPN company, was built on OpenVPN. Okay. Right. I'm a big proponent of it. Manson Lehman have deep open source backgrounds, and we fundamentally believe in the good that those communities achieve, or the best code is submitted through pull requests and it raises the tide for all developers. I believe in that. At my core, I really do. And people think we're evil and that we don't. The truth is, when you combine it with a cryptocurrency, it is now possible to hijack that IP, to hijack the code, to fork the public network, to create volatility for everybody else's coin just because you're in disagreement with the core. Okay. Now, people think this is evolutionary and that protocols need to evolve by doing that. But the truth is, it creates instability. It creates a lack of trust. People start to question motives. We see a lot of politics being played, and we see no governance. Right. So, I got to say this, and this is, again, more controversial. These people are not going to love me any more than they already do. But we have managed to really win over, I would say, 85% of the development community. There's really that 15 to 20% of purists that are just never going to be convinced with it, and it's sad.
We call them the maximalists. You're not going to win over everybody.
Yes, they're maximalists, and a lot of it is just this philosophy of anarchy. And to complement anarchists, historically, I'm a student of history, European history, American history. Excellent catalyst for change. Right. Drivers of revolutions and overthrowing regimes. Terrible at governing new regimes. Absolutely terrible historically. And that's we just take history.
And also, sorry to interrupt, Jordan, but that's where we are right now. Let's get real. Yes. We've already addressed the anarchy. We're there. We're now at how do we transform? How do we govern in a really innovative way? And that's what you're about. And that's the difference of what the original white paper for Bitcoin stands for.
Yeah, and it's not popular, Brad, but the criticism is we're not for everybody. And the truth is, we are for everybody that they're not considering. We are going to get grandma onto the ledger. We're going to get mom onto the ledger, and they won't even know they're using the ledger. The ledger will be like AWS is to a website. Right. We just host it. We power it. People won't even know they're interacting with it. It will just make the world fairer, faster, and more secure.
Right. And that's a very exciting, conclusion to the interview. It's been an absolute privilege to talk to you. I certainly have learned so much more than I anticipated in many aspects of your design. Clearly, you are an enterprise solution.
I appreciate you saying all that, and I can't thank you enough for having me. And congratulations again on the success of your channel and your community. If your community has any questions, I am very active on Twitter, and they're more than happy to reach out. I'd love to answer those questions, and I'd love to get more involved. And if anyone in the community wants to learn more about Hedera, they can find us at hashgraph.com.
So hashgraph.com, also Twitter. Don't forget, guys, this is just the beginning for the conversation. It's certainly in the beginning phase of what is going to be a very exciting decade, if not many more, for Hashgraph as a company. It's been a serious privilege and an honor to speak with you today, and hopefully we'll get a chance to speak with other representatives of Hashgraph in the future. Jordan Fried, you are an asset to the community, you're an asset to your company. I look forward to speaking with you again, Jordan, in the future. I can't wait to find out about what's happening, next year as you develop into a much more robust entity, much more well-known around the world. But right now, Hashgraph, check them out wherever you can, and we'll talk very soon.
Thank you very much.
Thanks, mate.